In this video, I'm going to be looking at the multiplying and dividing fractions and mixed numbers worksheet. Okay, so find that worksheet and follow along. We've done part of it, but I'm going to go ahead and do a video for the whole thing. Okay. So the first question is looking at what multiplying really means, trying to illustrate what you're really saying. So when you see 1/2 times 3/4, that really means you're trying to do 1/2, take 1/2 of 3/4 of some whole amount. Okay, so we can illustrate that by thinking about some rectangle representing the whole and going through this process. So if I need 1/2 of 3/4 of some whole, here's the whole, right, the rectangle. I need to take 3/4 of that. So I'm going to cut the whole into 4 equal pieces, pretend these are perfectly equal pieces, and I need 3/4 of that, which means I would be shading 3 out of 4 of those pieces. So now that's 3/4 of a whole. Now what I'm going to do now is take half of that. So if I take half of that, okay, if I cut that in half, then I'm talking about just these right here, these 3 pieces. Okay, let me erase that little extra. Try that again. Okay, just these 3 pieces right here. Okay. All right, now what we got to do is try to name that quantity. So when I name it, it's not going to just be 3 out of 6 pieces, because I have to name it in with respect to the whole. So I'm going to think about taking that dashed line and extending that, and notice that the whole is now divided into 8 of these little pieces. 1, 2, 3, 4, 5, 6, 7, 8, and we've shaded 3 of them. So the answer to this question should be 3/8. Now, notice when you're looking back at the original problem, 1/2 times 3/4, notice that we could get that by just taking 1 times 3 and taking 2 times 4. Well, it turns out that's exactly what the algorithm for multiplying fractions does. You just multiply straight across and then make sure that you simplify if necessary. All right, so with this next problem, we're trying to do 2/3 of 15. 15 is not a fraction. It'll help to think of it that way. So if we have a whole number 15, that's the same as 2/3 times 15 over 1. It helps sometimes just to put that 1 there so that you can see the 15 is up in the numerator, just like the 2 was. So now we're going to multiply straight across. So when we do that, we're going to get 30 on top, right? And then multiply straight across on the bottom, taking 3 times 1, we would get 3. And then here you might be thinking 30 divided by 3 to get 10, or you might be simplifying like we were doing earlier by dividing by that common factor, and you might think 10 over 1. If you do think 10 over 1, you need to be sure to go on and say 10 divided by 1 would just be 10. 10 should be your final answer. Right, now for 2/3 times 5/6, they're already both fractions, so I'm ready to do the algorithm of multiplying straight across. When I do, I get 10 on top and 18 on the bottom, but both of those are even. I can tell that because of the last number being divisible by 2. So I'm going to start by dividing by 2, and I get 5 over 9, and then 5 and 9, there's no number that goes into both 5 and 9 evenly. So that would be my final answer, okay? So for multiplying, you do not need common denominators. You do not need common denominators. You can just multiply straight across and simplify if necessary. Now, when the numbers get a little bigger, this can be a problem since you don't have access to a calculator. So I wanted to also share with you that we could modify that a little bit. Look back at the 2/3 times 5/6 problem. Notice right here that we can see there's a 2 on top, and isn't 6 2 times 3? So like there's 2 on top, and really that 6 is a 2 times 3. So I could have knocked out the 2's at that point because 2 divided by 2 is equal to 1 whole. I could have divided by 2 on top and bottom right there and then gotten the 5/9. On that problem, that's not that important because 10/18, those numbers are pretty small. It's relatively easy to see what divides into both of those evenly. But when you get to dealing with larger numbers, sometimes it's really helpful to understand that rather than multiplying first, like you could first multiply then simplify, but rather than doing that, you could simplify first, then multiply. That can be very helpful. All right, now how we normally show that is a little different than I showed it here. Typically, if you've got a problem like let me write the original. If you got a problem like 2/3 times 5, 6, what you tend to do rather than what I showed is you say 2 goes into 2 once, divide 2 into 6, it goes 3 times. Then you see 1 times 5 would be 5, and 3 times 3 would be 9. That's typically what you write, okay? All right, so the strict way of doing it, like following that algorithm that says when you're multiplying, you multiply straight across, we could do that. And 5 times 18, we could use our multiplication chart if we needed to get the 90. And down there at the bottom, that would be 225. We could do that part. But then here we have these large numbers, and we have to think about how to simplify those. Okay? And so then when we do that, we might notice the 0 and the 5 means these are both divisible by 5. But we have these large numbers to deal with. If we wanted to do that, we could go to our multiplication chart, look for 90 under the 5 column, and we'd see 18 on the other side. But notice that turns out to be 18. Well, that's because 5 times 18 was what gave us the 90. Do you see that? So we kind of already knew 5 would go into the numerator. And then if we divide 5 into 25, we could do it on the multiplication, try it on the multiplication chart, but we'd run into some problems here. Because if you go down 5 on that multiplication chart, you will not see 225 because 5 actually goes into 225 45 times, and that's not in our chart. So if you were doing it this way at that point, you would be sitting there having to do the division yourself, saying 5 goes into 22 4 times, subtracting the 20, 5 goes into 25 5 times, right, and getting 45, okay? And we don't want to have to do that. Okay? So what we could do is notice that 5 is on top and 25 is divisible by 5. We could simplify first, and the way you actually typically do it is you say 5 goes into 5 once, and if you notice down here, 5 goes into 25 5 times. We could knock out the 5 before we even get started. But let me back up a moment because 18 over 45 isn't even fully simplified yet. So back to the previous problem, I would have to then notice that 9 goes into both of these and divide 9 into the numerator and denominator. And I'd wind up with my final answer being 2 over 5. Well, if I'm going to use the simplify first idea, I might have been able to notice that because while the numbers are small, like just 5, 18, 25, and 9, I can see that 9 would go into 9 once and into 18 twice. All right? So then I could multiply straight across and get 2/5. 1 times 2, 1 times 5. All right? So let me show that again. So the idea is if you're trying to multiply 5/9 times 18 25ths, right? If you're trying to do that, the original problem. Well, the algorithm says you multiply straight across, right? But don't actually get the numbers, just think this. Now, wouldn't it be true that if there was something common on the top and the bottom, we should be able to divide that out to get this in simplest form? And while the numbers are small, I can see that 5 would go into 25. So I might go ahead and choose to simplify that. Just think 5 over 25. 5 would go into 5 once, into 25 5 times. And then again, while the numbers are small, I can easily see 9 would go into 18 twice. So then I really just have 1 times 2, 1 times 5, which is 2/5, and I'm done. So typically this is what you show, but it's because the 18 is really 9 times 2, and the 25 is really 5 times 5, so we can knock out a 5 and knock out a 9. That's the idea behind it. So I really want to encourage you to work on understanding this, simplifying first before you multiply, so you keep the numbers small. Since you don't have a calculator, it really helps. All right, now if you do wind up with mixed numbers, you cannot just multiply the whole number parts. You can't just do 2 times 1 is 2, and then 1/3 times 3/4 and do that, which would be 3/12, and then simplify 3/12 and get 1/4, and think the answer is going to be 2 1/4. Okay, because it's not. Watch. If we change each of these mixed numbers into an improper fraction, the 2 wholes times 3 plus 1 gives me 7/3. And then the 1 times 4, 1 whole times, it cut into 4 parts, plus 3 would also give me a 7, but it'd be 7/4, and I'm multiplying. So 7's on top, 3 and 4 on the bottom. There's nothing I can cancel out to simplify that, so that would be 49 over 12. Now, if it starts as a mixed number, they're going to ask for it as a mixed number at the end, or they should. That's kind of the rule of thumb. So now, if I needed to take 49 divided by 12, go down the 12 column on the multiplication chart. You'll see 12, 24, 36, 48. And when you see that 48 and you look over here, you'll see 4. 49 would be just a smidgen past that. So 12 doesn't go into 49 evenly, but I can use my multiplication chart to do this scratch work. Okay? It goes in there 4 whole times with 1 left. So this turns out to be 4 1/12, not 2 1/4. Do you see that? It's not just 2 1/4. It turns out to be 4 1/12. Okay? So don't just multiply the whole number parts and the fractional parts. It sometimes works when adding, to add the whole number of pieces and add the fractional pieces, as long as you understand how to carry. But with multiplying, that is not going to give you the right answer. So don't multiply the whole number of parts and the fractional parts. It won't work. Okay? Change to improper fractions first.